The area of play on an American football field is 1.1 acres. We will round off 1.1 acres to 1 acre. If we could fill the football field with water 1 foot deep, we'd have a volume of 1 acre foot. If we record the time it takes to fill that volume, then we know the rate of flow that took place. If it took 1 hour to fill the football field 1 foot deep, then the flow rate is 1 acre foot per hour. Acre feet per hour is easily converted to cubic feet per hour. Use the conversion factor 1 acre foot equals 43,560 cubic feet. Now convert cubic feet per hour into cubic feet per second, using the conversion factor 1 hour equals 3,600 seconds. We have shown that 1 acre foot per hour equals 12.1 cubic feet per second. These conversion factors lead to a simplified equation for determining the volume of water, which results from a known CFS flow rate. This fundamental equation, used in managing reservoirs, simplifies all the conversions. CFS is multiplied times hours and divided by 12.1 to calculate acre feet directly. Note that 24 hours is almost evenly divisible by 12.1. This means over any 24-hour period when a constant flow rate in CFS is known, CFS times 2 is a good approximation of the volume of water in units of acre feet. The simplified equation allows us to convert CFS flows over time into volumes. CFS flows might be going out of a reservoir through a spillway or coming into a reservoir from river flows. Calculating the volume of water which results from a net flow rate enables us to see how the reservoir elevation changes from inflows and outflows. Modifying this simplified equation using algebra gives the CFS flow rate when the volume in acre feet and the hours are known. This form of the equation is useful, for example, when we want to solve for the spillway flow rate in CFS that will get us to some target of available space. Moving forward, we will use an understanding of the simplified equation to complete exercises which use the simplified water equation in reservoir management decisions. Here's an example of an exercise we will use to get practice using the basic equation. Calculating inflows into Canyon Lake based on the change in volume in the lake. Another example we will work through uses hydrographs prior to and during a storm. We will be thinking about the change in available space which will result from alternative spillway releases. Building available space prior to the arrival of storm inflows and during a flood event is a critical skill. Our goal in the upcoming exercises is to use the basic equation to build your skills in thinking about the flow of water over time, the volume of that flow, and the impact of volume changes on reservoirs.